So lesson 3.2, truth tables, a problem-solving tool. Truth tables. For the next 3 to 4, maybe even 4 to 5 lessons, we are going to be we're going to be doing truth tables. And to do a truth table, you have to learn some rules. Don't copy that graphic yet. Okay, that's just kind of a little intro splash thing. We're going to get to it very quickly. I guess we will right away. So your first connector we're going to talk about is AND. And you notice up in the top left corner, and first of all, remember that sometimes we call that in logic a conjunction, whereas this, or, we call a disjunction. So, conjunction, and if I say to you, you guys all know this already, if I say, there is class today, and there is no quiz. I'm basically I'm making two promises to you. And the only way I'm going to tell you the truth is if I am follow through on both of them, right? And so, do you notice in the truth table, if I have, we have class today, and we will have no quiz. Notice the only time when the AND statement is true is when I follow through on both of these guys, and they're both true. Every other time, notice the end result is a false. So, here's your first rule. And only true when both are true. That's as quick and short as I can make it. Only true when both are true. Okay? And can you see that in this little truth? By the way, let me explain why there's 4 lines. This is all the combinations of true and false for 2 statements. I mean, this is it. This is every single possible way they could be connected. They could both be true, they could both be false. One could be true and the other one's false, and the other one's true and the other one, I mean, that's it. There only are 4 possibilities. So the idea of a truth table is to cover every single possible combination. Okay, and in this scenario, the only time I can tell you the truth with an AND statement is when both are true. Okay. At the bottom corner I have this, 2 to the nth lines are needed. N stands for the number of statements. You probably have seen that before. Doesn't that look like the subsets statement? Remember how there were 2 to the nth subsets? Well, in a similar way, there are 2 to the nth lines needed in a truth table, depending on how many statements. Now we only have 2, so 2 to the 2 power is 4. If we go to 3 statements, we're going to need 8 lines in a truth table. If we go to 4, we're going to need 16. If we went to 5, we would need 32. Yeah, we're going to hang around 2 most of the time, okay? We'll do a couple 3s, maybe a rare 4. But this is kind of the world most of the time we'll be living in, taking 2 at a time. So there's your first rule, okay? The second rule, well, this just shows you, I don't know if anybody's using the website that I pointed you to, but this is all up there, and sometimes done in a little bit nicer way. Okay, next. Now, I got to explain, I keep calling this OR. Actually, this is the inclusive OR. Yeah, see how I have that written in quotes underneath there? Inclusive OR. Okay, that means this OR says you can either have one or the other or both. That's what we mean by inclusive. There are other ORs. I think I hinted this, like the inclusive OR. If you get a GPA of at least 3, or you have an ACT score of 35, then you win the scholarship. What do you think they're going to do if you have a GPA of 3 and you also have an ACT that's high enough? Well, they're going to give it to you, right? So that's an inclusive OR. It's okay to have both. But here's an exclusive OR. He either made the field goal or he did not. You can't have a third possibility. Oh yeah, he made it and he missed it. That just can't be. So that's called an exclusive OR, and we're going to have that one in a minute. By the way, just so you know, the exclusive OR is not in the book. So you got to watch for that. All right. So when is it okay to have an inclusive OR? So in the top example, he got the ACT score high enough, and he had the GPA high enough, he got the scholarship. Case 2, he got the ACT score high enough, but he didn't have a good enough GPA, but he got it because it said he needed 1, or. Here, he didn't get the ACT score, but he did get the GPA. He got it. But alas, the last step, he did not get a good enough ACT score. He did not get a good enough GPA. He did not get the scholarship. So, this one I like to remember as only false when both are false. So, only true when both are true. Only false when both are false. Then I'm starting to get into the hand thing. I warned you about the signals. Okay. We'll uncover here. I don't know quite why I had that covered up, but here we go. Okay, now, I gotta warn you, this one's not in the book. This is not in the book. It's the exclusive OR. And the symbol that's commonly used is a circle with a little plus sign inside the circle. Okay? So, up here you'll see me do this. Okay, yeah. See here, you can't have both. It's like, okay, I had to go to the bathroom. I didn't see if the guy made the field goal or not. Did he make it or didn't he? Yeah, he missed it and he made it. Yeah, right. That's not a possibility. So do you notice how when both are true, please notice this. They can't both be true. How can that be? Either he made the field goal or he didn't. So notice I circled this one because this is the one that is the most shocking. Okay, you can't have both. But do you notice the rest of this is the same? It's okay to have one and not the other. It's okay to have the other and not the one. And again, you fail when you have... So this is just like this guy. It's exactly the same as this guy with the one exception of the top line, where you can't have both be true. Okay, so I like to remember it this way. True only when the two statements are different. By that I mean different truth values. One's true, the other's false. One's false, the other's true. But when they're both the same, they're both false. They're both true. So this one's only true when the truth values are different. Okay, so let's see. Let's go back. Only true when both are true. Only false when both are false. Only true when both are of different values. Okay? And these rules, you really, if you don't learn these rules and really have them, this is going to be a difficult chapter. These are not hard to learn. And if you learn them, it's going to make things go pretty smoothly. Now this one is so easy. This is the negation. And I mean, I don't even have to teach you this one. You all know what a negation does. It basically does the opposite. If it was true, the negation is false. If it was false, the negation is true. So you probably don't even have to remember this one. But let's throw it in there. Now we got this rule. The rule for this is, what should we just say, the opposite? Okay. Okay, let's try them again. Only true when both are true. Only false when both are false. Only true when they're different. Opposite.
Okay. I know, somebody should say, no, 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 you only use hand signals when you're in kindergarten. I think they help. Okay, here's another symbol that you will be seeing in this chapter. It's like an equal sign with a less than and a greater than sign kind of surrounding. And this indicates what we call equivalence. If two statements are equivalent, then their truth tables must come out exactly the same. And I think what we're going to do is let's illustrate I know you know one. Why don't we do one of those De Morgan's laws? Because we know those work. So let's pick a De Morgan's law and let's prove that they really are, the two sides really are equivalent. So, get this thing turned on. Okay, here we go. Let's do and let's show that that's equivalent to this might be a little too much at once, and I don't know if I left enough space, so I'll tell you what, I'm going to just move this slightly. And okay, now I look in my statement, I notice I only have two letters. So over on the left, I'm going to put a column for each of those. We know we're going to need an A and a B because I can see those letters. We're also going to need a not A and a not B, so I'm going to make a column for not A and a column for not B. It's getting kind of crowded, so I don't know, I suppose I should put some columns. I should have used graph paper on this. Don't need to go down that far, but I guess. And here we just need one column. One big fat column. Okay, so what we need, because we have two statements, we need 4 rows. The standard way to set up a truth table is to go, the first column, just go 2 of each. The second column, just go by ones. In other words, see, we went TTFF, second column, go by ones, TFTF. That'll give us all the possibilities. All right? So if that's what A and B are, then what's not A? Well, it's just the opposite of the A column. And what's the opposite of the A column? Instead of a true, we have a false. Another true, that's a false. Another false, that's a true. And what's the opposite of the B column? You see what I'm doing? Just using the opposite rule. Okay. Now, we're going to leave this column blank for a moment. We're going to come over here. I want to do A and B. Okay, that's one of the new rules we learned today. What's the rule for A and B? Only true when both are true. Okay, in the first row, are they both true? A and B? Yes. Are they both true in the second row? TF. Nope. Are they both true in the third row? Nope. Are they both true in the fourth row? Nope. Okay, and now for kind of the final answer on the left side of the equivalent sign, we have to negate that. So here's going to be, I'm going to just put an asterisk here, indicating that's kind of my final result now. What's the negation of these? What's the negation of a true? False. Negation of a false. True. Negation of a false. True. Negation of a false. So this is my final answer, so to speak, on the left side. Now, if my right side comes out the same as that, that tells me the truth tables are identical and they really are equivalent. Okay, let's do it. Well, I only need one row for this because I already have a not A and a not B. Here they are. And what's this rule? Only false when both are false, right? Only false when both are false. So let's do it. False, false. Only false when both are false. Yep. False, true. Only balls. Only balls. Good grief. Only false when both are false. Let's see if I can get my lips and my tongue working here. Only false when both are false. Well, they're not both false. And the last one, only false when both are false. And so, now compare the two sides. FTTT, FTTT. Do you see how the two are exactly the same? So therefore, what did we prove? We just proved that those two things really are equal. Actually, you just proved a De Morgan's law. Something that I've been telling you has been true. It's a good thing it came out, because otherwise I would have been lying to you all this while. That would not have been a good thing, and I probably would have been fired. Okay. So, here's an example of using a truth table to, let's say, to show that two statements are the same thing, are equivalent. Okay? Let's get back and see what I had next. Yeah, some problems here. Okay? So here's a couple problems from your assignment. Let's look ahead to number 30. Before I go any further, your first assignment for next time is to learn and think, how many rules did I give you? 1, 2, 3, 4. You got to learn. So for next time, nail those 4 rules. Okay? I mean, just know them cold, so you don't have to look at anything. Okay? Quick review. Only true when both are true. Only false when both are false. Only true when they're different. Opposite. Okay? So step 1 for next time. Nail those things. This is not written now. This is just, you're going to have to do a little bit of memory work. And the thing is, I'm going to be adding to this list in class the next few days. So they're not going to be a ton more. I think altogether we might have 7 or 8. And so you've already got half of them. But when there's more of them, then it's easier to forget them. So jump on them right away. Okay, now here are a few of the problems from the 3-2 assignment. Let's do number 30. Let's make sure I interpreted this correct. Number 30 in the book says, construct a truth table for each statement. Okay, number 30 is not P or not Q. So do you see that sitting right? You see here's the problem right here in the red box. So why do I have all these other rows? Now this is totally, there is no one way to do a truth table, but I think the technique I'm going to show you will serve you well. I always set up a column for P and a column for Q. And then if there's some knots, I reserve another column for those too. So do you notice how I have a row for P, a row for Q, a column for P, a column for Q, and then I have separate columns for not P and not Q. And then finally, the final result, not P or not Q. Okay, standard truth table. First column, half and half, TT, FF. Second column, go by ones, TF, TF. Okay, now do the opposites. The opposite of P, false, false, true, true. The opposite of Q, false, true, false, true. Okay, now put those two columns together using this rule. What's this rule? Inclusive or? Only false when both are false. Okay, so look at the first row. False, false. Well, that means that's why that's a false. Only false when both are false. They're not both false, so it's not false. They're not both false, so it's not false. They're not both false, so it's not false. Final result, FTTT, truth table complete. So there's number 30. Now let's take a look at number 32. This one's a little bit more complicated because it's got some parentheses. It says, take the negation of not P or not Q. This one's too much like the other one, so I'll tell you what. I'm going to just... Let's skip ahead to a different one. Sorry, that one was too similar. Let's go to number 37. And yes, this is an odd, and yes, this is one of your assigned problems. You're supposed to find P and Q or R. Parentheses, so we got to do what's in parentheses first, right? Please note, we have how many letters here? P, Q, R. 3. So I'm going to need 2 to the 3 power rows. I'm going to need 8 rows. Okay, a little different philosophy. See, I have a column for P, Q, R. But now, I got to go 8 rows. So in the first column, go half and half. 4 trues, 4 falses. So go by 4s. So T, 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 F, 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 F. Now cut that in half. Go by 2s. T, T, F, F, T, T, F, F. And in your third column, go by 1s. T, F, T, F, T, F, T, F, T, F. That little technique will always give you the grid you need to get all the possible outcomes. Okay. So, let's get to it now. This is what we have to do first because it's in parentheses. Okay, what's the rule for this? Well, we've had this so many times already today. Only false when both are false. Q and R, only false when both are false. So only look at these two now. True, true, they're not both false, so it's not false. True, false, they're not both false, so it's not false. False, true, they're not both false, so it's not false. Here we have false, false. Aha. So the result is false. Okay, next, true, true. Yeah, they're not both false. True, false. They're not both false. False, true. They're not both false. And on the bottom, there it is, FF again. False. So I did this column next. Now, this is optional, but I copied column P over here just so it would be closer. You don't have to do that, but you notice I just took this column and duplicated it here. Now, here comes the final job. We have to do one of these guys. And this rule is only true when both are true. Okay, so here we go. True, true. I'm looking at these two now. True, true. That's a true. True, true. Again, they're both true. The third one is also TT. And the rest of them, we don't have both trues, do we? So here's, by the way, this is just my little convention. Because that middle column over here was our final answer, I always put some kind of a marker at the bottom, like an arrowhead or something, so that everybody knows, hey, that's our final result. The final truth table for this is TTT, FFFFF. Okay. Truth table complete. So really, all you got to do is learn a few simple rules about how to make the P and the Q. How many rows do you need? And then all you got to do is learn the limited set of rules that I'm giving you, and it shouldn't be very hard. Don't learn the rules, and something that's not very hard is not easy at all. So obviously you need to nail those. I don't know, should we do number 38? Or did we just do this one? That's awfully similar, isn't it? Let's do this one. And by the way, you won't find this one in the book. Remember, the book ignores this symbol. It doesn't do the exclusive or at all. So, but I still expect you to be able to operate with it. So here's an example that wouldn't be in the book because it's got that. So do you notice what it is? It's P for parentheses, not P, exclusive or Q. Okay. So obviously we have to do the parentheses first, right? And what do we need for columns, our pieces? Well, we need a P and a Q. Good news, we only have 2 letters, PQ, therefore we only need 4 rows. Like I told you, the majority of your problems will probably be 4-liners. You might see, you'll have a few 8s. Because I have a not P, do you see that I added a not P column? And I copied Q, you don't have to do that, but okay, now let's do it. Now let's see, who remembers this rule? That's what's in parentheses, so we're going to do that first. That rule was what? Only true when they're different? And so as you look at this, this here, these two are different. False, true. Therefore true. Not different. Therefore false. Not different. Therefore false. Different. Therefore true. So here's our what? First result. It's not our answer, because all we did was the parentheses. So because it's kind of our what? Our partial answer, I made a put a little mark down there, an asterisk. Now what am I going to do with that? I'm going to take that answer and OR it, this kind of an OR, with P. Okay, so take this and OR it with P. This rule is only false when both are false. Okay, here we go. True, true. Only false when both are false. That's true. True, false, true. They're not both false. It's true. Here they're both false, so it's false. Not both false, so it's true. Final result. Arrowhead or something. Arrowhead's a pretty good way to do it, because then you don't have to circle the whole column. Okay, so we got just a few rules. I know it's a little bit different. You're going to be doing some truth tables. You're going to have to set up, you got to decide how many columns, how many different columns you need. Here's where some like grid graph paper, the nice thing about that is it helps you keep your rows lined up. But you know, you can do it on a regular line paper too. Maybe just throw a couple whatever. Off we go. Anybody have any questions? We got more rules coming, so just let me remind you, we've got a written assignment, which is, anybody look it up? I will, it's on the net here. And then don't forget you got some memory work to do. So I'll call up our web page and we'll check on the assignment. Maybe I have a slide here. No. So we'll check it out on the internet. I usually have somebody in class who's ahead of that and has looked, but not this time. Okay. See, we're not connected. Nobody looked, right? This could take a while, especially they don't seem to be connecting. I know what we can do. Okay, now we're connected. You're probably wondering why there's a computer board here. You're going to see there's a reason for that. Actually, those are called logic boards for good reason. They actually have logic. The same logic I'm teaching you literally is in those circuit boards. And we're going to be talking about that a little bit. But anyway, the 3-2 assignment is 1 to 51 the odds.